Okay, so today we're going to do adding and subtracting radical expressions. So, when adding and subtracting radicals, you treat them like variables. Only like radicals can be combined. Often, radicals must be simplified, and that's what you did in yesterday's lesson, before you can add and subtract. So, 5 root 5 plus 2 root 5 minus 3 root 5. Very similar, and this is the way you should be looking at this, to 5x plus 2x minus 3x. And so if you combine all those, you would get 5x plus 2x is 7x, 7x minus 3x is 4x. So same thing goes here. If you have 5 root 5 and you add 2 root 5, you get 7 of them. So 7 root 5 minus 3 root 5 is 4 root 5. Same thing for b. It's all like radicals. 6 root 7 subtract 2 root 7 is 4 root 7. Subtract 7 root 7 is minus 3 root 7. Root 3 plus root 3 plus root 3 plus root 3 is 4 root 3s. Okay, so the next one has, terms that have a root 11 in it and some that don't. So make sure you're only combining the like radicals. So for instance, you can only combine negative 5 root 11 and a 9 root 11, which would give you a 4 root 11. And you can only combine the 7 and the minus 9, which gives you a minus 2. You cannot put that together. It's like saying 4x minus 2. Can you combine 4x minus 2? No, that's the answer, right? Okay, then we get into ones that look like E, and you can't actually add them together the way they're written. However, if you simplify them, you can add them together. So, what can I take out of root 12? Well, there's a perfect square of a 4 I can take out, so it becomes 2, and I'm left with a 3, plus, in the radical 27, the perfect square that I can take out is a 9, so that becomes a 3, and I'm left with a 3 inside. And then, of course, now, because they're like radicals, the root 3s make it like right radicals, it would become 5 root 3 is my final answer. So same thing goes here. The 28, there's a 4 that can go out. Now, you got to watch here, and maybe I'll show every single step here. The root 28, that's 4 times 7. So the 4 will kind of come out. Not kind of come out, it will come out. And when you square root 4, it comes out as a 2 and a root 7. However, there's already a 2 already there. So what happens to it? Well, when the 2 comes out, it gets multiplied by the number that's already there. So then we become 4. So we get 8 root 7 minus 4 root 7 gives you 4 root 7. Okay, let's look at the rest. Root 75, 25 can come out as 5 root 3. 48, there's a 16 that can come out, so 4 root 3. And 27, there's a 9 that can come out, so that is 9 root 3. Sorry, when the 9 comes out, it should be a 3 root 3. And when I combine that, I get 5 and 4, make 9, and 3 is 12 root 3. Next one. Again, the 50, you can take out a 25. It's 25 times 2. When the 25 comes out, it's a 5. There's already a 5 already there, so we need to multiply it, and we get negative 5 root 2. 32, that's a 16 times 2. When the 16 comes out, it's a 4, and there was a 9 already there, so now I need to multiply the 4 times the 9, and I get 36 root 2. And what do I get as my final answer? That would be 36 subtract 5, which is what? 31 root 2. 4 root 3, can't do much with that, so I'm just going to rewrite it as 4 root 3. The 20, I can take out a 20 with a 4. Square root of 4 comes out, and I get a 2. And it gets multiplied by 3, so I get 6 root 5. A 4 can come out of 12, so that's another 2 when it comes out. So that's minus 4 root 3. And a 9 can come out of 45 as 3 root 5. So in this case, we have 4 root 3 and a minus 4 root 3, which actually will just cancel. And then we have like radicals of root 5, 6 root 5, and a 3 root 5 is a 9 root 5. All right. J. 100 can come out as a 10 root 3. 63, a 9 can come out as a 3, and there's a 9 already there, so that would be 27 root 7. And 108, if you didn't know it was 49 times 2, no, let's try that again. What you would do is keep on dividing by 2 until you find out what this can have as perfect squares. So this is what, 27, that's 3, and that's 9, and a 3, and a 3. So it looks like you can take out an 18. But 18, sorry, I said that wrong, a 36. 36 times 3 is 108. How did I get 36? 2 times 2 times 3 times 3, or 6 times 6. So 36 comes out as a 6, and I'm left with a root 3 inside. I'm going to combine only the like radicals, so I get 16 root 3 minus 27 root 7. That's my final answer. Now watch, this one has a cube root. That means I can only take out perfect cubes. So just to refresh your memory on perfect cubes, well, 1 is a perfect cube, but you'd never take a 1 out. The next one is an 8. Then we have a 27. Then we have the next perfect cube would be a 64, and I think we're too high at this point. So if I take out a perfect cube of 8, cube root of 8 is 2, and I'm left with a cube root of 2 inside. For 54, that's 27 times 2, so if a 27 comes out, that comes out as a cube root of 27 is 3, and I'm left with a 2 inside. So again, they're like radicals, so I can put them together as 5 cube root 2. Don't forget the cube part of the cube root. So this one, watch, I'm trying to trick you on this one. There's a cube root and a square root. You can only combine like radicals together. So what is the cube root that goes into 250? So going back to this, the next one after 64 would be 5 cubed, which is 125, and 125 goes into that, right? So if I cube root 125, I get 5. There was a 6 already there, so that's 30. Cube root 125 was cube root 2. Now this is a perfect square. 100 can come out as a 10, so minus 50 and root 5. And we can't do anything else with that. We would just simplify. So now we have variables in here. So this is a little bit harder, as you noticed in the last lesson. Again, you can only combine like radicals together. So 6 root a, 5 root a, and minus 11 root a. What would I get? Well, 6 and 5 make 11, and 11 root a's, and I'm going to subtract 11 root a's. They all cancel, 0. The next one we actually have to simplify here because it's not going to actually work out. So any perfect squares I can take out. So 25 I can take out as a 5. A squared I can take out as an a. And b I can't, so I leave it as root b. Plus 4 I can take out. 2 square root of a squared. A, I can't take out the b. So does everybody see the variables are the same? So I can actually add 5a and 2a together to get 7a with the root b attached. So over here, again, I can only combine like radicals together, so the x's and the y's can only go. So 2 root x and 5 root x make 7 root x. Minus 3 root y plus 2 root y would be minus 1 root y. Over here, again, like radicals, so the cube roots can only be combined, and the square roots can only be combined. So 8 cube root 2x and a minus 5 cube root 2x would give me 3 cube root 2x. And a 7 root 2x and a root 2x would make a 8 square root 2x. So don't be swayed that you can combine these because they're different radicals, because one's a cube root and one's a square root. Okay, next one. Watch here. Now, this is a cube root, which means I can cube root 8 and get a 2, and I already had a 5 there, so that makes 10. If I take a cube root of x out of there, x cubed, I would get an x, right? Now, watch. The next one's a square root. So if I take perfect squares, remember 75 is 25 times 3, so I can take a 25 out. That's a 5. 5 times 4 is 20. Now, watch this y here. Only the square can come out. So when you can take the square out of the square root, you get just like the square root of y squared is y, and you already had a y, so now it's y squared. And inside the radical, we still have a 3 and a leftover y there. Okay, next one, square root 27. Perfect square would be 9 times 3, of course, so the 9 is going to come out as a 3. So it's going to be minus 3 times 2 is 6. Now, you might want to look at this. Y to the power 5 is y to the power 2 times y to the power 2 times y to the power 1. Everybody agree? If I take out a square root, a y squared and a y squared out, I will get y times y, which is y squared. So I'm going to get 6y squared, and I'm still left with a 3y inside. 50 is 25 times 2, so I can take a 25 out, and that's a 5. So minus 15x root x. I can't take out that. So again, don't be combining things you can't combine. So does everybody see? This is like this, x, and this is not like. So 10x minus 15x root x. And then the only thing I can combine is the 20y squared minus the 6y squared, which is 14y squared root 3y. Okay. So again, this is getting more complicated, so I would highly advise writing this out, showing each step. So maybe I'll do that in this one. So watch. 32, what's the perfect square? So that would be 16 times 2. What's the perfect squares for a to the power 5? Well, that would be an a squared times an a squared times an a. Does everybody see that? So take out the perfect squares. The 16 would come out as a 4. 4 times 3 is 12. One of these and one of these a squares are going to come out. So then I'll have an a squared that is left, because I'll have a squared comes out as an a. Another a squared comes out as a, and a times a is a squared. What do I have left? I have a 2 and an a left. Okay. Now I'm going to change colors, and I'm going to do the next one just so we don't get mixed up. So I'm going to write this as minus 2, and then in the square root, I'm going to write the perfect squares. So that is a 9 times 5. And then I have a b squared times a b. So the 9 can come out as a 3, and then you have to multiply it by the 2, so you get minus 6. The b squared can come out as a b, and then I'm left with, inside the radical, 5b. All right, I'll change colors here. Now we're going to do this one. So that's a 5b already there. I have a square root, 125. That is 25 times 5. And that's just a b, so there's nothing else I can take out. So the 25 can be taken out so if I square root 25, I get 5, and there's a 5 already there, so that would be plus 25b, and the 5b is still in there. And I'll use black this time. So watch this. I'll maybe go up. So this is a minus 2a, and the 72 I'm going to write as a 36 times 2, and then that's an a squared times a. So again, the 36 can come out as a 6. 6 times minus 2 would be minus 12. And a squared can come out as an a. There's already an a there, so I get an a squared. And then I'm left with what's inside as a 2a. So is there anything I can combine? Oh, look at that. 12a squared and a minus 12a squared with a 2a can cancel. And can I add these together? Oh, look at that. I can. So what's my final answer? What's 25 minus 6? That would be 19. B root 5b.